Hello, my name is Esteban Pardo. I am a Passivhaus designer and architect and Passivhaus certifier. I would like to start by thanking the platform for allowing me to give this presentation, as well as everyone for participating and listening. I hope you enjoy the presentation. I'm going to talk about an office building in Vitoria, La Rioja. In 2018, the international footwear brand Victoria decided to build its new headquarters with offices and a logistics warehouse to consolidate its growth in the footwear sector. The Victoria brand was founded in 1915 in La Rioja. I expect you are all familiar with La Rioja. It's known not only for its wine, but also its gastronomy, its landscapes, and its people. And the company decided to locate its new headquarters in the municipality of Arnedo, which is located in the southeast area of the province of La Rioja in the Zidacos Valley. It's the third largest town in La Rioja. And the characteristic is, thanks to the success of the footwear sector, it accounts for most of the economic activity in the area. And one of the most famous brands is the Victoria brand, not just due to the number of years that the company's been operating, but also because they use organic materials, for example, natural cork, and they also combine craft techniques, for example, sewing, manual sewing, and also the production close to the area. You know, Alicante, for example, is a major hub for production, and La Rioja is also. So, within specific projects, which may prompt companies to adopt this approach and seek sustainability, well, all of these models are sustainable. And they're 100% recycled. They're made from 100% recycled materials, all made from natural materials, in other words. To strengthen this commitment to energy efficiency, Victoria decided that its new buildings should comply with the Passivhaus Plus criteria. Its new headquarters will comprise a new office building, 1,815 square meters, and also a logistics warehouse. The specific location is shown here on the slide in the La Maja industrial estate located in the Arnedo municipality. It's a unique industrial estate because it's located in the countryside. The clearer marked sections would correspond to the office buildings. The darker shaded building is the logistics warehouse. There's virtually no shade on these buildings. The building to the west, there's also a hillside 60 meters to the west, which would not project any shade or shadow. There's also different changes or in the level of the terrain, but none of this is going to cause any shade. It's a clear area with no shadow or shade at all. So this would be the floor plan, the general floor plan. And we can see, for example, the location of the logistics warehouse and the office building. The office building is perfectly integrated in the volumetry of the logistics warehouse. And then you can also see the loading bays, the changing areas, the changing rooms, and the offices for the workers. And then there's also a loading patio. And to the north, the automatic storage system and the automated logistics system. It's a pioneering system in the footwear sector because it allows all warehouse organization to be automated fully. Then there's a more conventional area, and the rectangle that you can see To the left, the west wing is a 3-story warehouse for prototypes and design samples. And if you look opposite the office building, there's a garden area where deciduous trees have been planted because the idea is to provide more shade in the summer. The office building faces south, which complies with the strategy to improve shade in this area. These are the different floors in the office building. It has 2 floors. It's divided into 4 modules with patios in the middle to take advantage of natural light. And then you can see the ground floor in the second block. There's a main entrance and the elevator shafts, meeting rooms also for visitors. On the left in block 1 is the showroom, which is almost like the treasure room. That's where they present the annual summer and winter collections. And next to that is the meeting room. The meeting room was designed with a terrace or in like staggered form so that from the upper section people can view the entire collection. And then in block 3 there's a museum archive with historical archives. Then after that you have the canteen, offices, the rest area, and then other sections for specific collections. On the first floor includes the entire design area for the development of samples. There's a design office there and also a materials storage area. And then also there's the management, administration and accounting offices or departments. And then there are open offices for the different departments as well. If you look closely, this would be the thermal envelope. You have a partition wall with the logistics warehouse, but it's very insulated. The compacticity was 0.5 in this part of the building, which is not that bad. Well, this slide shows the elevation, the main elevation, the south. I mentioned that there was a slope, as you can see there, 5 meters, a change in height, together with a sunken area in the southeastern section and also a ledge of about 5 meters in the easternmost corner. And that 2.5 meter sunken area is a characteristic of this plot. If you look on the west facade and the southern facade of the office building, well, they are glass facades, which makes it very difficult, and this requires solar protection systems. Here's some other sections which allow us to compare the volume of the logistics warehouse of the offices. Section B clearly shows the skylight in the office building, which serves not only for natural lighting of the staircase, but also to fulfill the strategy of ensuring compliance with Passivhaus requirements for the building. And longitudinally, we can see that the blocks are divided by or separated by the patios, and the first block has that section of terraces, tiered terraces, and the showroom as well. This is the layout or the construction layout of the office building. We can see that the envelope against the floor is 15 centimeters, 10 centimeters thick. The facade has 8.5 centimeter thick cladding with recycled cotton insulation, and then rock wool insulation 16, and a sandwich type panel 3 centimeters with a relatively low transmittance value of 0.13. The roofing comprises alveolar panels, thermal insulation 220 centimeters XPS, other dependent layers, another XPS layer, and then the finishing layer. And finally, the middle partition walls are panels with insulation of 4 centimeters XPS, and we can see that the offices are separated 10 centimeters so that thermal insulation can pass through 10 centimeters, and then recycled cotton insulation. Carpentry used is Carmen Premium 120 aluminium wood with a frame 0.99 and also glass transmittance values there shown, and double glazing 18 more or less. In terms of interior materials, an effort's been made to mainly use low energy incorporated materials, wooden structures, wooden carpentry, natural woods, and also recycled cotton insulation. Here you can see the different floors with the different shading systems and passive cooling systems. The main cooling strategy or passive cooling strategy used here consisted of window automation on facades and in patios to allow crossed ventilation currents and also convective ventilation. All of these facades to the exterior have sandwich type or Chinese sandwich type shutters or blinds, which are regulated using a centralized control system, which also provides solar protection control. And all of the patios have awnings to cover the patios and avoid direct sunlight from entering. This slide shows the shade calculation model, which we consider to be useful in order to calculate the shade factor in patios. And the results are striking because they were different to the ones that we'd initially estimated. And to calculate thermal bridges, we used Fixo. The ones that you can see on the right are those that were prolonged by the metallic structure that was assembled in order to support the shutters or blinds. Here you can see the layout of the air conditioning and ventilation system. There you have the specific details of 2200 and 1300 system, a tree-type distribution using metal sheeting ducts or conduits, and also different ventilation grills that worked at level 2 at constant pressure. In this way, the airflow was actually proportional to the quality of interior air. In terms of active systems, 3 heat pumps with a total technical power for installed or a total installed heating power and 73 cooling power. Distribution was through interior units, fan coil type interior units, and also insulated conduits. For the roofing, photovoltaic modules were installed, correctly pitched, 30 degrees ventilation. These were used for self-consumption purposes, for communication systems and for technical equipment. The certification values are the ones shown here on the table. There you can see the heating demand, which was very low, precisely due to the effect of the sunlight, in contrast to heating demand. Primary energy was approximately 33, as you can see there. That's primary renewable energy. Therefore, the Passivhaus Plus standard is complied with. I'm very quickly going to show you some photographs of the construction work, which was divided into 2 phases. The first phase, which went from July 2018 to February 2019 for the logistics warehouse, which was completed, and the office building structure. From February to November 2019, the work was carried out on the office building. This photograph shows you the finished structure of the office building in 2019. And here's some photographs of the enclosures in the patios and insulation of the facades and carpentry. There you can see the metallic superstructure that I referred to before for the installation of the blinds. In terms of the partition wall, you can see the insulation and the hermetic sheeting was passed as shown in the picture. Here we can see photographs of carpentry installation work. Installation of the sun protection blinds and also the logistics office. This is the hermetic membrane. We use the Intello membrane because we felt this was the best option for interior insulation. This photograph shows ventilation equipment installed on interiors in the logistics warehouse with the extraction and impulsion conduits. On the left, you can see the ventilation ducts and air conditioning ducts and also a ventilation grill. These were the ventilation equipment installed on the roofing with the impulsion and extraction ducts. The facades had microperforated aluminium panels. This served very much like the external fabric of the building. Interior finishing, well, as you can see, we used different wood structures for acoustic performance purposes. And here's a series of pictures of the finished building, which shows you the main vestibule and also the largest work area in the offices. And here's a view of the showroom and the meeting room. Well, very, very quickly, I would like to highlight the details of an economic study that we carried out between the model that would fulfill the technical code and the Passivhaus model, Passivhaus Plus, that is. If you look closely, the Passivhaus model provides an energy consumption saving of 43%, 45,600 kilowatts photovoltaic power generated, which means that the real band of energy is reduced to 60,764 kilowatts per hour per square meter, with an annual saving of 0.12 euros per kilowatt, 15,118 euros. The Passivhaus Plus additional cost would include it was estimated 197,000 euros, 9.3% of the budget, taking into account legal interest of 3%, 3.8%. This gives an amortization period of 16.4 years. On the other hand, on the next slide, you can see the different monitoring temperature values. When monitoring all of the parameters, environmental and energy consumption parameters, environmental quality, with the active and passive systems in the building. These graphs show the monitored temperatures. I've just shown 2 weeks as an example. The first at the top left shows between 3rd and 9th February 2020, with minimums of 4 degrees and maximums of 15.52 degrees. And you can see that interior temperature ranged between 26.6 the first day, Monday, and minimums of 19 degrees on Sunday after the weekend. In the summer, a week from 6th to 12th July was used as a reference. Minimum temperatures fell to 14 degrees, maximums 38, and interior temperature ranged between 17 and 22 degrees. And finally, the final slide I'd like to show you corresponds to CO2 values in relative humidity. In relation to the details on this slide, in the first months after commissioning, different flows were identified. They were slightly higher than initially estimated, as you can see there, with a flow of 5,300 cubic meters. And we can see that CO2 limit requirements or maximums were complied with, but it was on the threshold of 45, more or less, which was too low. There were also complaints about excessive airspeed in some of these spaces. Later, at the end of spring, the system was modified to operate at constant pressure flow, and that pressure level was reduced. The flow was reduced by about 60%, with a maximum total flow of 1,800 cubic meters and renewal of 0.12. With those low flow levels, it was confirmed that CO2 limits were maintained, and we managed to increase relative humidity to between 60 and 31%, or around 45, which we consider would be fine. And in terms of environmental parameters, that would be perfect and also provide better user comfort. Okay, well, that's the end of the presentation. I hope you found it interesting. Please contact me if you have any queries or doubts. Thank you very much.